First of all, apologies for not being in Toulouse today, but the last minute flu has prevented me from traveling. It has been really a pity for me, and I really have wanted to be there with you all today. Objective of SEREN. Well, the objective of SEREN is to improve the Northeast Atlantic wave and physics forecast by improving mainly the forcings, namely the surface currents and the winds. There is a few differences with the Kailani project. In the Kailani project, that the previous one that we had, what we had here, we have just 3 pilot sites, one in Galicia, in Tarragona, and in Gran Canaria, and this time we are extending the whole methodology to the whole Northeast Atlantic area. For that, also we need to take into account that we are not only dealing with coastal winds anymore, we're also dealing with offshore winds. We'll talk now about how we will deal with that. And we have a few set of objectives. One of the first objectives have been already achieved. That is the one marked in green, that is identified the benchmark periods. We will see that in a moment. And we are working just now in developing neural networks for the predictions of the winds of the surface currents. The forthcoming challenges that we have is to develop algorithms for examining the blending between the artificial neural networks and the operational forecast data, namely the European Center winds and the EBF currents, and also to test these artificial neural network winds and surface currents with the models that we have in the EBMFC, namely the waves and the physics. Who are we? In the SEREN team, we have 4 institutions involved. We have Meteo France with Lotfi and Alice as part of the EB Wave and experts on the SAR and the CFUSAT. We also have involved as new members the ECM CSIC with Marcos Portabella and Eugenia, that are experts on the scattering products, and also they are really aware of the WindTAC products. Also, we have CESGA as the HPC provider, and it's also the HPC provider we have at the EB and the EBMFC. And also, Now Systems, of course, as part of the EB Wave, the experience in neural networks, and the coordination of the project. Expected benefits of SEREN? Well, from the spectral wave model side, if we improve the winds at the coast, we will have better wind diffraction, that it's very needed for coastal dust streaming applications. And also when we're having difficult maritime conditions near the coast. Also for the offshore side, offshore winds, we can improve the swill partition. And for the physics, mainly the thing is that improving the winds, we can get better wind circulation, but especially storm surges improve the peak, especially in the storm surges forecasting. Also, another factor is that the neural networks are really fast in inference, so correcting the forcings does not involve a lot of computational cost. And also taking note that one of the main challenges of this project is how to combine the SAR data that we can see here in the figure with the scatterometer ones into getting a consistent with product. What's the methodology that we propose in this SEREN project? What you can see here in the upper part will be the business as usual that we have in the EB Wave system, and we have in the lower part of the slide in green will be the new version after the SEREN project. This example covers the EB Wave part. From the EBF system will be quite similar, especially the part related with the winds. So what we're proposing here is adding to the business as usual winds from the European Center 2 neural networks. A first one that will be trained with scatterometer data, that will be for the offshore part, and another second one that will be for the coastal part, trained with SAR wind data from the Sentinel, and with this information from these 2 neural networks blended with European Center forecast, generate the new wind forecast. For the currents, we have chief riders at specific areas, and in these specific areas we will train specific networks, and those networks will serve to correct the EBF forecast that we will need to use for the EB Wave as forcings. One of the first milestones in the project, as we said before, was to select the proper benchmarks for the artificial intelligence neural networks and for the posterior simulations. And what we can see here is the results of the analysis done by Stefania's group. This is with the EV wave for the last 4 years, and we can see here is how the bias of the significant wave height, the mean wave period, and the maximum wave height has varied. Here in there will be the vertical axis will be the months, and the horizontal axis will be the different subregions of the EBV. It's very similar to the same plot that we're having in the quiz for the EBV or the EV wave. We have, thanks to that, we have spotted the areas where precisely the model does not perform very good. So essentially, the areas that we have, the periods that we have selected is the ones that are marked in black in these black rectangles. That are essentially the early spring in 2023, and also the autumn 2023, and also part of the winter of 2024. That will be the benchmark for Seren. And now, to wrap up the presentation, I will present a really very brief example of how these artificial neural networks can enhance the coastal wave forecast. What we can see here is the wind neural network that compared with the European Center. We can see here is that the neural network is able to produce lower root mean square error than the European Center. In some areas, for instance, the Atlantic French coast or the Cantabrian Sea, close to 40%. That is quite remarkable. What about the surface currents? Well, so the surface current you can see here in the EBV has certainly biases and have certain errors. There's very high scatter index, and the directions that not match very well what the same that we get with the HF radar. So using an autoencoder architecture, we were able to improve this performance, and we can see here is that we correct a lot of significant part of the bias. We didn't at the current state the scatter index still remains really high, and the extreme date and the extremes are not as well captured as we would want it. But we can see here that, for instance, we're correcting a lot of bias in the speed, and particularly also at direction, because we are getting directional biases, the directional sectors much better. But one of the main limitations that we have is that we have a very high data scarcity at the extreme data. Well, and just to finish, what we have here is the answer to the previous question. So does the neural networks improve the coastal forecast? The answer is yes. Here is a simulation done by Lothi's team. What you can see here is the contour simulation that will be the present version of the EV wave in blue, and the buoys in black, and the TOT that will be the red one, that is the one that combines both the neural networks from the winds and the currents. And you can see here that is the best simulation, because it's the one that gets better both the significant wave height, we are getting better the peak and the storm Arwen, and also we are having important enhancements in the mean wave period, essentially due to currents. Finally, what are the next challenges that we are facing in this project? We have identified 5. The first one is to continue with the coastal wind neural networks with the SAR data. We need to extend the temporal extension, and also to add new zones from the Mediterranean and the Northeast Atlantic. Also to start working in the offshore wind neural network with scatter radar products. We need to find a way to blend consistently both the coastal and offshore neural networks products. In the part of surface currents, we need to extend to new sites, especially in Gibraltar and the Skagerrak area. And we need to test it in the EBV and EV wave systems. Thank you very much, and apologies again for not being there today.
So thank you very much again for your presentation, Manuel. You got a big applause from the room. So I think now that we can move.
Good afternoon, everyone.
To the next presentation, which will be by Andrea on the ocean reanalysis algorithms for climate studies project.
Okay, thank you everyone. Hello, and I'm Andrea Cipollone, and I'm responsible for this service evolution project, this ORACS, so ocean analysis algorithm for climate studies. So such algorithms are a model-based algorithm. So we are talking about a series of studies, experiments based on model reanalysis, on models, and the focus is to support the production of long-term reanalysis, in the sense that to extend that backward in time before the altimetry era. But let me introduce a little bit the team here. So there is a quite large number of people, I would say, but so there is a long experience in the reanalysis production and also in centennial reanalysis production and ensemble generation, and also in the studies of biases and smoothing schemes to reduce the impact of biases on the reanalysis. So we are well fit, I would say. This project is important for many other products rather than the global physical analysis, since with this within the product we would like to understand which are the main algorithm that can be used to preserve the continuity of the reanalysis in the presence of observation network change. And with observation network change, we mean a change in the number of observation, a drastic change in increase or a decrease in the number of observation that can induce discontinuity in the reanalysis. But this also can be beneficial for regional physical analysis, since they rely on external sources. So, for example, they rely on climatology or external time series for the boundary conditions. In the case they extend to the 80s, for example, so before the altimetry era. And we also are going to carry out a series of experiments for the definition of biases coming from external forcing, like atmospheric, so using different atmospheric forcing and runoffs. So will be beneficial also for near real-time products. So the project focused mainly on two different transition periods. So here they are highlighted. So the deployment of MBT and XBT. So the introduction of solid-state physics, and the second period is the launch. So is the transition period where the first altimetry satellite has been launched. So the 90s, within the 90s. And the approaches that we are going to follow are basically two. So there is first post-processing, or at least one method is rely on the smoothing altering, so a post-processing tool to reduce the biases in the end of the production, and again to remove the discontinuities coming from the sudden ingestion of this new set of data. And the second approach is the inclusion of an hybrid covariances in the assimilation steps to preserve the consistency there during this transition period. So let's describe a little bit the three different tasks. One, the first is the use of the hybrid covariances, and we are gonna apply it on two different periods. So as I was saying, the 90s. So we are gonna perform an analysis-like experiment using a depermitting production system that is at CMCC, that is used at CMCC, and we run it using hybrid covariances and with the flow-dependent part, so the error of the day. that comes from the SIGAR reanalysis, a SIGAR ensemble reanalysis at the low resolution that is covering the 19th century, the last century, basically. The same algorithm, so the hybrid covariances, will be used also to perform similar analysis, but in the 50s. In that case, using the low resolution one. The other task is a set of experiments to understand which are the biases coming from the boundary conditions. So this will be performed by analyzing the analysis increment over a long time period. For example, we run twin experiments with different atmospheric forcing, and by looking at the long trend biases in the increments, you could actually see which is the impact that the biases coming from different forcing. And this is the same we are going to do the same for different runoffs. In the picture you can see the differences in the mean absolute error differences in the sea surface salinity increments coming from experiment with two different runoffs, so one from a JERA 55 and the other from a reference or climatological runoff. Yes, you can see the difference. So in this case, you see which is the correction coming from using different forcing here. The last task is the smoothing analysis. So this is a post-processed algorithm that is basically working on the increment future, so working on backward and future increments in order to reduce the variability and high frequency variability, especially of the analysis, and provide a more realistic evolution of the time series. So you can see in the picture the oceanic content in the between 300 and 800 meters, and the dashed blue line is the analysis from low resolution model, resolution experiment, and you could see there is a quite noisy due to the impact of the assimilation increment that is ingested at once during the model evolution. And while the application of this smoother can reduce, can actually reduce and generate a more realistic evolution, and this is represented by the solid lines in orange and in green there, with different parameters, so smoothing parameters, so you can play a little bit, understanding which is the best, and without, so in the case you don't want to smooth a realistic evolution, of course. But this kind of smoothing can be also used to positively correlate the assimilation incrementing with the model tendency, so without risking to have increments trend and model tendency diverging too much. So, and this is, in conclusion, the objective of the proposal. So this is basically we would like to provide again some tools for to support the production of long-term analysis, and it will be beneficial not only for MFCs but also for TACs. In this case, in terms of informative content. And it's worth also to mention the fact that these methods can be applied to observation network changes that are not presently covered by the project, but can be, but that are present, of course, like for example the advent of meteorological satellite. And this is the last. Thank you.
Thank you very much, Andrea. So I think now we can move to the next project, which will be the last one. And I can see 3 people presenting, so I will let you present yourself.
No. Okay, so good afternoon, everyone. I'm Julia, and I'm coordinating the F3ZO project for freshwater fluxes in ocean forecast that many of you know as river forcing. And I don't have a nice slide with pictures to present the team, but I have Thomas and Louis who are here and work with me at Magellan. And they're actually doing most of the work. So if you have questions about river discharge data and AI method to combine them, please ask them. And we are also working with CNRISMAR, in particular with Andreas Torto, and with Alejandro Blasquez at LIGUS. So this was supposed to be an animation, but it doesn't matter. So why are we studying river discharge? So river discharge impacts the ocean in different ways. So it impacts the salinity through input of fresh water, and also it changes the mass of the ocean through the addition of mass. And on this animation, you should have been able to see that actually the freshening that we can see at the outlet of the Amazon occurs at a really high spatial and temporal resolution. So we need highly accurate and high resolution data sets for the river discharge to be able to model these processes. And at present day, it's not the case. So as many of you have explained yesterday, at present day, most ocean modeling systems use climatology for the river discharge, and many of you are planning to use other data sets to alleviate this limitation during this phase or the next. And the objective of the F3ZO project is to provide a better freshwater forcing data set that could be used to improve both ocean reanalysis and ocean forecast. And this data set will be based on artificial intelligence technique, combining in situ data, satellite observation, and hydrological forecast. So to do that, we intend to proceed in 3 steps. So first, we will collect and assess the quality of the existing river discharge data sets. Then we will combine them and provide accurate high resolution and global river discharge data set using data-driven artificial intelligence techniques. And finally, we're going to assess the impact of this hybrid data set on ocean simulations, mirroring both reanalysis and real-time products. So we are merging different types of data sets, so in situ measurements, hydrological model predictions, and what we call water mass balance data sets. So many of you may not know this kind of data set, so it's actually based on the simple principle that you can solve the water mass balance equations at the level of the river basins. And because we are able to measure the change in storage with GRACE and GRACE following data, and able to measure the vertical atmospheric fluxes, we can isolate river discharge. So each of these data sets has its own advantages and drawbacks. So in situ measurements are highly accurate, but there is not enough of them. The water mass balance estimates have global coverage, but are limited in spatial and temporal resolution, and they can be biased as well. And hydrological model predictions are highly resolved. They are available in near real time, but they suffer from significant biases that need to be dealt with before implanting them in a forecasting system. So here, for example, you have the river discharge for the Amazon for these 3 data sets. So in blue, you have in situ measurements. In orange, the water mass balance approach using GRACE. And in green, you have GLOFASS hydrological model predictions. So you can see that the mean discharge for GLOFASS is too high, the mean annual cycle is too high as well, and the annual climatology for GLOFASS there is a significant error of about 20% in the annual amplitude and in the bias, and the phase is not right. The water mass balance technique is doing better for this river, but it's not the case everywhere. So, for example, if you take an Arctic river, the Yenisei, for example, you can see that in situ measurements show you in blue snow well flood, which is really fast. And GLOFASS does catch part of this flood, but the water mass balance approach is not successful to capture fast events. So we did a similar assessment for 40 large rivers flowing into the oceans. So I'm not going to go into the details here, but basically the results are contrasted. If you look simply at the KGE score, which balances correlation, balance, and variability, it seems that GLOFASS is doing better than the water mass balance approach, except for 3 rivers. But if you look at other metrics, such as the seasonal cycle, the results are more mitigated. So we need a system to take into account the strengths of each system to have accurate river flows everywhere. And to do that, so we want to use AI-based hybridizations. So the training principle is that for the ground truth, we will use the in-situ measurements and the water mass balance approach, where the water mass balance approach has demonstrated high performance. For inputs, we will use the GLOFASS river discharge data and other ancillary data sets when available. All input data should be available in real time so that this approach can be applicable both for delayed time and real-time products. And we've chosen to use the long short-term memory approach, which is particularly adapted to correct biases and errors in time series. And last but not least, our collaborators at CNR are going to test the impact of this, what we hope to be improved river discharge dataset on ocean simulations, mirroring both reanalysis-like configurations and operational-like configuration. And you can see on this picture a result between 2 projects. So it's kind of the last result of the Womborg project and the first result of the F3SO project array. So it's the reduction of the sea surface salinity bias when you improve the river discharge dataset for all major rivers flowing into the Atlantic. And you can see that the sea surface salinity bias reduces a lot at the outlet of the Amazon in blue, but it reduces in the whole basins, basically. So this is it, and basically the F3SO project aims at improving the scientific quality of ocean reanalysis and forecast through the assessment and reduction of systematic errors in the river forcing. We will generate a new data set to estimate river discharge using deep learning to combine both hydrological prediction from GLOFASS with remote sensing data and in-situ observations. And we will test the impact of this hybrid river discharge dataset on ocean simulations. Thank you.
Thank you, Julia and the team. So it's now the time for the short Q&A session, I think. Yes. So there's no question on the Slido so far. I don't know if there are questions in the room.
Just a question for Julia on the impact of the availability of SWOT data that will provide much better estimation of a river inflow, what would be the impact on your project?
The impact of SWOT data.
SWOT observation. You didn't
On the river.
So you will have much better estimation of river outflow from SWOT observation, as you know. So what would be, is this something you want to analyze, assess in your project or not?
So we don't have access yet to river discharge dataset from SWOT.
Not yet, but they would come.
But if they become available, yes, we would be interested to at least compare them with what we have, and if possible, to include them in the system.
Are there other questions or comments? So maybe one comment from my side. So we have sea surface salinity product in Copernicus Marine. Because so this is also for the F3O project. So we have sea surface salinity product, because I've seen that you have used some from NASA on your first slide. So please use Copernicus Marine ones next time. Other questions? So maybe we can move to the next two presentations. So we have a special guest, 2 Horizon Europe projects that were targeted as Copernicus Marine Service Evolution Project, Focus and Necton. And we can start with Joanna, please, to present the Focus project.
I'm happy now to present the project, which is Horizon Europe project, funded under Earth Observations Go. And this is FOCUS. FOCUS means forecasting and observing the ocean to coastal ocean for Copernicus users. It is not only related to the Copernicus MFCs and tax presentations that we have heard a lot yesterday, but with the series of presentations today and also what we are going to listen tomorrow, you will see that there is a lot of cross-cutting activities of networking, which are very welcome in the months and the years to come. And I will give now a brief overview about the project without overloading you with many results, but I will show you the barcode that you can register and follow the newsletters, the results, as well as the deliverables, and use the information related to the data. And I will provide you also brief information about the partners and our relationships, what are our objectives, how we are trying to go from the observations up to the applications uptake and the communications. And why is the focus actually so important and relevant? Of course, we know that the coastal zones, they are heavily used and the impact area. These are the areas in which 40% of the Earth population lives, but they are also impacted for both climate change and human-made drivers. However, do we able to predict correctly the cost? Are our modeling skill well enough for predicting the cost? Do we need new tools or new data which actually serve the coastal modeling system? And this is why we consider that many efforts are still needed to reinforce the coastal capabilities and to enhance the coastal forecasting systems. And what is needed is innovative knowledge for the value change, having the seamless integration from the land to the coast, but also tailoring the information and the different products in order to meet the different policy needs and also the wider user requirements, because scientists, stakeholders, and users, they need to work together. Regarding the consortium and the partnership, the focus project consists of 19 partners among 12 countries along the European coasts and covering all European seas. We are aware not all coastal countries are representative in such a Horizon Europe project, but you will see connections at networking and transfer, and co-design will be made with all member states' coastal services. And our goal within the Focus project is really to improve, but also to enhance and advance our coastal dimension from the Copernicus Marine Services. This will be done through a novel integration of the high-resolution observational system. I will show you how, together with the hydrology. There were quite a few also presentations today related to the hydrology. We also focus on hydrology part, pan-European hydrology, but also what is very important, these are the improvements which are planned to be done together with the member state coastal system. So in that case, our stakeholders are all the member state coastal systems players, which is a bit different than the normal Horizon Europe project that identify just specific level of stakeholders. Here really target all of them. And these seamless coastal monitoring and forecasting systems, they will be developed jointly based on the different novel approaches, which will include the artificial intelligence, ensemble modeling for data assimilation, downscaling approaches, flexible interfaces, but also we will try to constrain better the coastal systems for targeting coastal applications, and these coastal applications have to serve the policy need. And last but not least, this is the harmonization and the standardization of the products that will be offered. You are aware there are many products, many data from the different services, but they need to be harmonized and also standardized to be widely used. And as I already mentioned, very important is that all this will be done with the co-production and co-design between the member state services and the Copernicus Marine Services. And the project is also endorsed as UN Ocean Decade project under the Coast Predict, which means that our target is also to go beyond the member state coastal services and to have the wide applications among the different continents. And we already have specified many other coastal systems outside Europe that it is related. The demonstrations will be integrated into the digital twin EDITU infrastructure, and we will have also a special session in a few months about how this architecture will be integrated. And there are very close connections with many programs regarding the applications, the different lighthouses within the ocean mission programs, but also the Green Deal and the newly started Lancelot governance project, in which also we will share the information and the applications and the data and include the wider stakeholders' importance. How the focus will be done? This will be done with the 3 pillars, which are very strongly connected to each other. And our main aim is really to achieve the seamless monitoring and the forecasting of the ocean by applying the existing and enhance the methodology, but also to develop the new coastal products co-produced with the member state coastal systems. And this will be done through enhancing the high-resolution observations that serve the coast, having the pan-European hydrology data. I will show it how. Then integrated this into the coastal models that are seamlessly integrated between the regional coast from one side and the land from the other side, showing the added value of the different applications. And Finally, we will do then the integrated Copernicus and member state coastal systems in order to make it operational and fit for use coastal information services, which are Europe-wide, serving all coastal areas and all coastal systems. And of course, our goal is to do that by joining efforts, and everyone who is sitting here is invited to networking and to contribute and to also exchange information with us. And because for us it is also very important that we go beyond the state of the art of the development, but also we increase the networking with as many as possible coastal services within the design and the evolution phase. And now, very quick information about these three pillars and the main task that we have. As I already mentioned, I will not overwhelm you with much of information. You can look at our website. I will provide it at the end. And regarding the coastal observations, our first deliverable is already ready, and in very few days it will be also available in the Focus website with the available high-resolution observational data. And starting with the high-resolution observational data, our aim here is to merge the novel remote sensing data, which are really with a high resolution, together with the coastal in situ observations towards the coastal observations improvement product. And our goal is to have the pan-European innovative coastal observational systems, which also responds the society and the policy needs towards the different demonstrations. And this is categorized in the different levels. This includes the enhanced coastal observations, like, for example, the high-resolution sea surface temperature, but many other parameters that are included. This includes data fusion between the remote sensing and in situ observations, like, for example, the sea level and currents, which is this application here. This also goes further towards the AI-based beach imagery for providing the better data, including, for example, the shoreline and how the shoreline is moved, or also the coastal and river data tracking for the pan-European river data flow. Then going further to connecting land to sea, what is very important in that aspect is to improve the land to ocean interfaces, and this will be done by improved hydrological modeling, hindcast and forecast for the river representation. In addition to that, when we have hydrology data, these data have to be linked in a smarter and better way to our coastal models. So within this task, we also work towards the novel techniques approaches that will be implemented into the coastal models, like AI-driven approaches or estuary box models, to integrate hydrology data into the coastal models, and they will be tested also within the coastal systems. The major aim here is to have the pan-European data network, which includes not only the freshwater discharge, but also it will include the information about the nutrients and sediment in both hindcast and forecast mode, as well as testing these into the different coastal models, and this testing will be done in the 1D and 3-dimensional numerical models. And all this information is aiming to be freely available. We have identified few of the test coastal areas, which are actually within the partnership, but then at the end of the project, the pan-European information, which comes from the EHIPE model and from the LISFLOOD model, together with the new modeling approaches, which are AI-driven box models for integrate coastal applications, will be available also for everyone. Then the third component, this is approved coastal models, which includes the integrating the different modeling system, but also how we can enhance the synergy between the models, the coastal models, and the new available observations. And this will be done through development of the multi-platform data assimilation approaches towards the coastal open ocean coupling, which is very important, and all these routines for interfacing between the regional Copernicus marine products and the coastal systems, they are also freely available, and we aim also to harmonize and standardize the interfaces from one side, as I already talked, land to the coast, but also what is very important is from the regional marine services towards the member state coastal services, but also we want to implement novel approaches. We are working towards the AI-driven coastal downscaling to use the direct Copernicus marine products and downscale to the coastal models, towards the ensemble data assimilation, or to using also the AI data assimilation as well. And these modeling approaches and new methodologies will be further developed in the different marine coastal systems. Then, going further, is about the applications. And these applications that we will test within the focus model, they are designed in a way to support the different member state requirements, but also the different policymakers. And in order to do that, we identify the three different fields of the applications. The first one are the applications to better manage and protect our coastal areas. And here we will provide the information about the coastal erosion, about the pollution, and the sediment tracking. The second one are those which are related to the blue economy, and these are the co-use of resources, for example, the offshore wind energy, together with the aquacultures. The third one is about the applications related to the natural hazard, but also to anthropogenic hazards, which include the heat waves, ecosystem degradation, storm surge, and waves. And all those applications connect the member state coastal system with the regional Copernicus system. And the aim is not only to provide the added value of our focus developments, but also to make an input towards the Ocean State Report and towards the further downscaling of the coastal services. And then finally, we proceed with uptake and communications. And here you can see a lot of information on our website. You can subscribe of the newsletters that have already been produced, and there are many results there. We have already done many meetings, also with the Copernicus User Forum, worldwide meetings to increase our impact, but also to co-design and co-develop our marine coastal services together with as many as possible member state coastal services. And what is very important is that we want to transfer our research and innovation developments not only to the partners involved in the Focus project, but also targeting the European member state coastal systems. Thank you, and if you have questions, I will be happy to answer.
Thank you very much, Joanna, for this very nice overview of the Focus project. Questions for Joanna? All clear? So no question, apparently. So thank you very much again. And I think we can move to the last presentation of today for the Necton project. And it will be given by Julien.
Yes, thank you, Stephanie. Hello again, everyone. So I will talk about and give an overview about the Necton project. So the Necton project is led by Stefano Ciavata, who cannot be here today, and he asked me to give this presentation on his behalf, so I will try to be faithful to this beautiful project with some participants in the room actually. So it's a really a nice project to be in, and I will try to convince that it's also important. So the motivation for this project, why Necton? So we hopefully all convinced here that marine ecosystem and biodiversity are vital. There are also systems that are under a lot of stress and give give a lot of also vital services that are also endangered by those stress. So there are some examples of effect of those stress on the marine ecosystem. And the idea of the Necton project is to say that if those, if we can predict better the marine biodiversity under those stress, we can maybe avoid some of the bad consequences, or at least mitigate some of them. So the vision of the Necton project is to go a bit beyond what has been done in producing some product for the marine ecosystem, and to go predict and help also to protect the biodiversity of those ecosystems, to help also to have a better management of the food resources. So here you see a video that has been produced by the project. If you go on the website, you can have the whole video of the Necton project, and with also some comment, probably better than mine, but yeah. And also, I'd like to say that Necton project is endorsed by the UN Decade for Marine Life Sustainable Development, and contribute to the Ocean Prediction Project. So, what we're going to do in Necton? We'll start with a situation where basically you have this monitoring and prediction of the marine ecosystem, so mostly biogeochemistry and lower trophic level. And we try to go to extend this view toward benthic data, benthic habitat, improve the biogeochemistry also at the lower trophic level, but also at the higher trophic level, so toward fishes and even mammals. And also to assess the marine pollutions, and also to assess the effect of the impact of the climate change on those ecosystems. And as I said, it's part of the UN Decade. So we apply in the Necton project, we apply a three-pronged approach. So it's not three pillars as in focus, but it's the same idea, I guess. The first prong is to have innovation, and especially for the process integration of all the components of the marine ecosystem. The second one is to use innovative method to merge or combine observations, data, and model. And the third prong is to develop technological innovation to have a better link between all those components. So I will go a bit deeper in those approach that will all serve different scenarios and case studies that are co-developed with end user, and it will also help to attract new user maybe to the Copernicus Marine Service. So we're gonna develop new product, new model. And this is, so maybe you don't have to go through all of it. Again, it's on the website. This is a list of the new product that will be developed within the Necton project. So it goes from, pelagic biogeochemistry, but also, as I mentioned already, benthic habitat, Necton, so fish, marine mammals, and also a series of stressors such as some pollutants or climate stress also. And we will produce those data into hindcast and also climate projections. So those data will be, at the end, will give some product that also we try to favor the integration of those products in the Copernicus Marine Catalog. And there is like a real collaborative work that is done to define new standards corresponding to these new products. So this is just an example here. And this is really a discussion that is ongoing in the Necton project to have a good standardization for all those new products that I already showed to you. One prong was this modeling framework interlinked. So in Necton, we use a framework called FABEM that meant to connect hydrodynamics with ecological or BGC component or model. And so basically the idea is that we have in Necton a series of BGC model, but also more high trophic level model, and also models that are more on the process level. And we can connect like everything a bit with everything, so that's the concept. So for example, you can run one biogeochemistry model with NEMO or with HYCOM. So there is a lot of flexibility to connect all those models. So this is really a work that has been ongoing, and which gives already some good result in Necton. I will probably give an example later on. I mentioned also this integration between data and models. So basically, we want to go from a situation where mainly the ecosystem data that are included in model are chlorophyll A with standard data simulation algorithm, toward a situation where we will use a large range of data with a lot of different scales and also types of data that are very different, with the help of advanced algorithms, including machine learning. All those new data, all those new algorithms will be demonstrated into a series of case studies that has been co-developed with stakeholders. I know why it's yeah. So here, this is the list of the case studies. So there are case studies that are more related to fishery management, and other are more on biodiversity conservation. And again, all those case studies are co-developed between Necton project and end users. And maybe to finish my presentation, maybe some key facts on the Necton project. So you have the list of all the partners of the Necton project on the right. So the project is okay. The slides are evolving automatically. I don't know why. So we have 23 partners in the Necton project. We are roughly at the midway into this project. And as I said, so it's all thanks to Stefano. It's all led by Stefano Servata that provides also this presentation. So if you have questions, I hope I can answer them. And thank you for your attention.
Thank you very much, Julien. Any question for the Necton project? All clear?
Ouais.
In case
some question pop up, you can send an email to Stefano.
Yeah, or post it on the Slido, and we will pass that to Stefano and the team.
Okay, thank you.
Thank you very much, Julien. So we are close to the end of this day, which was very long, but still we have some time. And I wanted to take the opportunity to have the production centers, TAC and MFCs, as well as some service evolution project partners and some Horizon Europe project partners as well, to exchange with you on the uptake of the R&D results from all those projects. Any ideas that you may have, issues as well, or priority. So I don't know if you have some ideas you want to exchange on specific aspects. So the floor is yours.
So we have seen yesterday in the TAC and MFC work plans that some of the projects that run during the first batch was already planned to be integrated. So I don't know if you have some comments on that, if it runs very well, or if you encounter some issues.
Maybe, Stephanie, you could remind the process, I mean, for interaction between the Service Evolution R&D project on TAC and MFC, in addition to what we have today, because as you explained very well, all those projects, they should, the objective is that they impact the TAC and MFC, at least by the end of the project. I mean, Necton and Focus is a bit different, but I mean, they will also impact. I mean, there are already some transfer of Necton activity towards the work plan of the TAC and MFC, but maybe if you can just remind the planning of the project on the different interactions that will take place in addition to what we have today.
So if we go back to the this second batch of Service Evolution projects, so you have seen the work plan, because the project have started in September last year. They will run for 2 years. So we have this first coordination meeting today. Then they will provide the midterm report at the end of the summer. I will provide them to you in September or October. And then we plan to have another coordination meeting, most probably in June 2027, so very close to the end of those projects. So I expect most of the projects to present nearly their final results at this coordination meeting, and then you will have also access to the final reports of those projects. And of course, the idea is not to wait the next meeting or the final report to exchange. So on one side, if the TAC and MFCs would like to exchange with a specific team, please feel free to do so. You can keep me in the loop, but I mean, just for information. We have already organized some specific meetings, remote meetings, between some MFCs and some of the Service Evolution project. Also physical meetings for the teams, for example, who are in the same city. But we have already started to have a specific meeting and exchanges. So if you'd like to have more, just come to me and I can ease the exchange. But also you can directly contact the TAC and MFC leaders or the PIs of the Service Evolution project. And as usual, the slides will be available so that you can come back to them, revise, and you will find the contact as well on the side. Yes, we have one question or a comment.
Okay, thanks. No, it's just a technical point. So I missed yesterday the information. So I heard about the 5 Hertz sea level anomaly data in the altimetry, and but I didn't know that the 1 Hertz will be dismissed soon. But this is also included the reprocessed data set or just the in real time?
I don't see people from the sea-level TAC or... Yes, sorry. Can you answer the question? Yes. Okay, so the question was, so you plan to dismiss the 1 Hertz in the NRT?
Yes, it's just for the NRT, not for the multi-years. Don't worry about that. And it's not for all the mission, not Cryosat and Altica mission. For all the mission NRT, the rest of the mission, except Altica and Cryosat, we move to the 5 Hertz at the end of the 26th. Except if you want to need more time, and we can discuss about that. It's okay? Yes?
So the new one, the new reprocessed data, so the extension of the multi-year product will be 1 Hertz still, okay.
Yes, and if you need data for test, it's available on Copernicus, or in Aviso, it is not available on Copernicus. It depends on the product you need.
Okay.
So what is the planning? How long is the overlap between the 1 and the 5 Hertz data sets for near real time?
The plan is to frozen the data set.
No, I mean, but so people who are simulating the 1 Hertz will need to have both at the same time to test.
It's now, yes.
Oh, sorry.
And over 1 year. So normally you have long
okay,
time
sorry,
series.
I apologize. I was
no,
not
it's
aware.
okay.
Yeah, thank you.
I think the two are already available for testing and also implementing your So I repeat for the people online, maybe the two are available since 1 year, and I pass you the mic if you want.
Just to specify that last year we introduced the 5S, but 1S is still available and will be retired in by the end of 2026. So you have still time to test and check. No, the wave data, the 5S are not yet available. They will be. Yesterday, the plan was shown by the WaveTAC. It will be 2026 and 25. So by the end of this year, we should have the new 5S. And then we will have to leave a few years to you to take on board this new data. And we will most probably do the same that is happening for sea level.
Well, yeah, thank you very much.
You're welcome.
And if you have all of the questions about that, you can send an email or at me or Isabel for details.
Okay, additional questions, comments? Yes, Julia?
Thank you. So we are planning to generate a new river discharge dataset, but we don't know about the requirements. We are planning to generate a new river forcing dataset, but we don't know about the requirements of the different MFCs regarding the river, the temporal coverage, the spatial coverage, the resolution. So it would be really helpful for us to know more about the requirements of the MFC regarding this dataset.
So what I can suggest, if it's useful, is for you to prepare a short questionnaire that we will pass to the MFCs, and so that you can get feedback. And we can organize that, I guess, with Valentina a little bit more widely. We can start with the MFCs, but we can send it also to Copernicus Marine users, selected users. So Valentina is used to do this kind of questionnaires to get feedback, and this is a good, a good idea to get refined requirements from the users. Yes, Emanuela.
Thank you. So exactly one question for the service evolution S3O. Sorry. You mentioned you are going to use GLOFASS data, but you are going also to integrate in your data set the EFAS data set, which has a higher resolution and that can be maybe more suitable for the regional MFCs.
So we have not planned to integrate EFAS yet. Maybe it's something that we can consider. There is a bit of work in changing, but the idea was to provide also a global river discharge data set, and I'm not sure that EFAS is...
It could be maybe added for the regional areas, for example, European regions, in addition to the GLOFASS, maybe for the regions which are covered by EFAS, I don't know, you can consider to use EFAS dataset which has a higher resolution.
It's something that we need to consider and what we can do within the time frame of the project as well. It might be quite time consuming to change the system now, but we can definitely considering and try a comparison on one or two rivers maybe to start with and see if we get improved result with EFAS.
If I may jump into this, I saw in your slide very nice results from Andreas Torto, I think, about the RIN impact in the North Sea. So maybe if you are going to test the EFAS, maybe not many river of your list is going to be covered by EFAS, I'm sure of that, but RIN probably is there, so we can start with the RIN. Because for the Norwell Shelf and EV, Northeast Atlantic model, it will be very interesting.
Okay, it's something that we'll consider and we can get back to you about specifics.
Yeah, thank you for the question. Actually, this is very relevant because in focus we will use EFAS, and then it's maybe interesting to compare GLOFASS with EFAS. We will do the pan-European, which are based on EFAS, but plus including the different variables. And the first data set is going to be provided this year, and of course at the end of next year there will be pan-European data set based on EFAS and EHYPE, the pot.
Yeah, definitely it's a good idea to compare the outputs of both projects.
Play. Last question, comments? Okay, if not, so thank you again to all the presenters of this afternoon and to all participants. And let me wish you a pleasant evening and see you tomorrow.